At one point in the last video, I mentioned the expected value of a random variable. Most of you probably already know what that means, but it's just an average, except that we are weighting each potential outcome that can occur by its probability. For example, let's say that X is some metric that we're going to use to make a decision. This could be a present worth, or a benefit cost ratio, or a rate of return, but whatever it is, here's the notation for the expected value of X. Now we're equipped to go back to the concept of risk neutrality that I had also mentioned in the previous video. If a decision maker is risk neutral, what that means is that they are effectively indifferent between a certain outcome with a particular value and an uncertain situation that has the same expected value. As long as the outcome of the uncertain situation is the same in expectation as the certain outcome, the decision maker doesn't care. What that means is that effectively the decision maker does not put any sort of negative value on uncertainty itself. Consequently, we can use all of the same decision rules that we've already learned throughout the semester, just putting an expected value sign in front of whatever decision metric we care about. We can say that a project then is worthwhile even if it's uncertain, as long as the expected present worth is greater than 0, or as long as the expected rate of return is greater than the hurdle rate, a decision would be justified. I had mentioned that this is somewhat of an unusual situation to have a risk-neutral decision maker, so let's put that to the test and see if you yourself are risk-neutral. This is like one of our reveal preference experiments that we had done earlier in the semester. So imagine that I am willing to give you $100 right now. I'll put it in the mail, send it to wherever in the world you are. However, I'm also willing to gamble. I'm going to roll a standard six-sided die, and if it lands on 1, I'll give you some prize. Otherwise, you get nothing for 2, 3, 4, 5, or 6. And what I want to know is how large would the prize have to be for you to choose to take that gamble instead of taking the free $100 that I would offer you with certainty. Take a moment and think about it, come up with a number in your head, and then we'll discuss. If you are risk neutral, then you would assess this situation by saying, I've got a 1 in 6 chance of winning something, and because I'm risk neutral, I'm indifferent between taking the $100 for sure right now or taking the gamble as long as the expected value of the outcome is also $100. With a 1 in 6 chance of winning, that would mean that I'm indifferent as long as the prize equals $600, because 600 times 1 over 6 is going to be $100, and that's what I can get for certain. If you would take the $100 for sure, unless the prize was more than $600, that's a situation called risk aversion, and that's most of us. Most people are risk averse, meaning that we'll only accept uncertainty in exchange for a better expected value of the outcome. Otherwise, we prefer the sure thing. As long as the prize is greater than $600, then the expected value of the gamble will be greater than $100. The extent to which the prize that you named is greater and greater than $600 tells you something about exactly how risk averse you are. Some of you may have also come up with a number that was less than $600, in which case you might be what's called risk seeking. That means that you actually get some utility from the process of taking the risk, or that you derive some happiness from the uncertainty in the situation itself. So mathematically, risk aversion is the idea that if you have an uncertain situation, people are willing to sacrifice some amount of expected value in exchange for greater certainty in the outcome or greater control. That means that we're effectively evaluating a trade-off between the expected value of a project and the variance associated with its uncertainty. From an economic standpoint, this tells us that we are risk-averse if the utility associated with the expected value of a gambler's outcome is greater than the expected utility from the gamble itself. If we go back to the utility curves that we talked about early in the semester, then we can graphically see what that expression means before writing out the equation itself. So remember, we have this situation where our utility increases as a function of wealth, but we have diminishing marginal returns. So the first derivative of our utility curve is positive, and the second derivative is negative. In this example, we had two possible outcomes. Either we get nothing, or we win $600. There was a 1 in 6 chance of winning the prize, and so our expected value of the outcome is $100, and we can plot the utility associated with that. Next, we want to look at the expected value of the utility of the gamble instead of the expected value of the outcome. So we had 0 and $600 as our possible outcomes. We can look at the utility that we get from those two possible outcomes and take the expected value of that. In this case, we still have a probability of 1 in 6 of getting the higher level of utility. And so our expected utility from the gamble would be at a point more like B. And what we can see is that the expected utility from the gamble is less than the utility of the expected value of the outcome. So mathematically, these are our 2 points on the utility curve. We have the utility of the expected value of x as point A, and B is the expected value of the utility of the gamble x. If we are risk averse, that says A is greater than B. Mapping this back onto the discussion of certainty versus uncertainty, we can see that point A is more like taking the sure bet of getting $100 from me without having to gamble anything. That's the expected value of the gamble, but I'm offering it to you for free without any uncertainty whatsoever. However, if I decide to take the gamble, now I have two outcomes with respect to how much utility I'm going to end up with after the gamble takes place. So the expected value of the utility of taking the gamble is less than the utility that I get from the sure bet. In the next video, we'll expand this simple concept to a more realistic engineering economic analysis based on the case study that we had talked about on the very first day of class.